So in the previous videos, I have discussed how to calculate molar mass, and I discussed how to calculate um, moles and particle conversions, and now we're going to focus on mole and mass conversions. And in order to focus on mole and mass conversions, we should go back and look at the mole flow chart real quick. So we're really going to be focusing on the left side of the mole flow chart here, where we have mass and moles. We're just kind of focusing on the go between the two of them. So when you go from mass to moles, I'm telling you that you need to put 1 mole on top and molar mass on the bottom, which is something you're going to have to calculate. And we go from moles to mass, we're going to use molar mass on top and then 1 mole on the bottom. So we're going to work our way through a few of these problems, or actually a couple, and then we'll move on to the last section. So taking a look at problem number 1, it asks how many moles. So in problem number 1, we're solving for number of moles. And we were given, or we're asked to find the molar, or we were given 28 grams. So we have grams of carbon dioxide. So that tells me that if I'm starting with mass, I'm going to look at my mole flow chart. I'm going to start with mass on the left side and work my way to moles, which means I'm going to use this math right here. So I'm going to have 1 mole over the molar mass. So that's what I set up here. But we have to first remember to calculate the molar mass. And if we remember to calculate the molar mass correctly, we would identify that in carbon dioxide, C, there's only 1 there, which is why I have a 1 here. And then there's a 2 behind the O, so that's why I have a 2 here. So I'm going to take 1 carbon times the mass of carbon, which is 12.01, and 2 oxygens times the mass of oxygen, which is 16, and I get 32. And then I add those together and I get the molar mass of 44.01 grams in 1 mole of carbon dioxide. So again, going back to my mole flow chart here, it says that if I'm going to go from mass to mole, my molar mass has to be on the bottom. So that's what I put the molar mass at the bottom right here, and I put 1 mole on top. So again, just like we did with our earlier set of problems, we were going to multiply straight across and then we're going to divide, right? So if I take 28 grams of carbon dioxide times 1 mole of carbon dioxide, I'm going to have 28.0 grams of CO2 on the top, and 1 times 44.01 is 44.01 grams of CO2 on the bottom. And hopefully we can see that grams of carbon dioxide cancels out, and I'm going to be left with moles of carbon dioxide. So I'm going to grab my calculator and plug those values in, which this one isn't that hard to do. So I'm going to take 28.0 divided by 44.01, and the calculator gives me an answer somewhere around 0.6362190411. No, you don't have to write all those things. I'm just going to tell you to go to 2 decimal places. So 0.6, we're going to round that to 4, and that's going to be moles of CO2. So it's going to be my final answer. And so that's when we are asked to go from mass to moles. So now we're going to go and look at one more example. And in this case, the example has me starting with 5 moles of Fe2O3, and it's asking me to calculate the mass of Fe2O3. So this time the problem tells me that I'm going to be starting with moles and I'm going to be working my way to mass. So I'm going to follow this arrow going from right to left, which tells me molar mass is on the top. So that's something I have to calculate, and 1 mole is going to go on the bottom. And so in this case, I could just simply skip right ahead and put 1 mole of Fe2O3 on the bottom, and then I'm going to go ahead and calculate my molar mass. So we're going to look at Fe2O3, and I see that there's a 2 behind the Fe, so I'm going to need 2 Fe's. And this time, remember, we're going to get our information from the periodic table. And so when I locate iron on the periodic table, I see that its mass is 55.86 grams in 1 mole. And when I locate, and so when I multiply that out, might as well take care of that right away. 2 times 55.86 gives me 111.72 grams in 1 mole of Fe. And then we have to look at our oxygen, which in this case, there's a 3 back here. So I'm going to take 3 oxygens times the mass of oxygen. On the periodic table, the mass of oxygen is 16.00 grams in 1 mole. And I'm going to multiply that out. 3 times 16 is 48. So that's 48.00 grams in 1 mole of oxygen. And so then the next step of this, I'm going to add these two values together. And so I'm going to take the 48 plus the 111.72, and I'm going to get 159.72 grams in 1 mole of Fe2O3. And since we already put 1 mole at the bottom, I'm just going to transcribe the 159.72 grams of Fe2O3 on the top. And now all that's left is to do the math. So if I multiply these fractions straight across, I'm going to take 5 times 159.72 and 1 times 1. So I'm going to take 5 times the 159.72, and the calculator gives me a value in this case of 798.6, and that's going to be grams of Fe2O3. So my final answer here is pretty big, but it's the right answer. And so that's how we do the both types of problems of mass to mole conversions. So again, looking back here, when you go from mass to moles, you have to find molar mass, and then it needs to go on the bottom of the second fraction. And when you go from mole to mass, you need to find molar mass, and it goes on the top of the second fraction.